Hey, it's Mr. Stellatano. This video is going to explain how you convert from moles to mass and back from mass to moles. So the way we're going to be doing this is using dimensional analysis. Now when you first look at this, you're going to be thinking to yourself, why are we doing some more complicated math to do this? Why can't I just do it in my head? The first couple examples you can do in your head, just to show the process, but in a minute we'll show why it's really important to use this process. So the first question we're trying to solve here is how many grams are in 2 moles of water? So the first thing you do for any of these problems is you always write down the given. So we are given 2 moles of H2O. That's what we're starting with. We know we're going to be using dimensional analysis, so we need to multiply by some fraction that is equivalent to 1, right? A fraction that equals 1. So the first thing I know is I want to get rid of, I'm going to multiply this by a fraction. I want to get rid of my moles of H2O, right? So right off the bat, I'm going to go ahead and take my fraction, and I'm going to put that 1 mole of H2O on bottom. We're always going to be using 1 mole somewhere in our fraction that we're multiplying by, so somewhere in our conversion factor, in other words. So just keep in mind it's always going to be 1 mole that you're using. In this case, moles went on bottom because we want to get rid of the moles that are on top over here. So whatever you want to get rid of, you always put those units on bottom. Now, the next thing we have to keep in mind is that we need something that's equivalent to 1 mole in order to make this fraction, because this fraction has to equal 1 total, right, if we're using dimensional analysis. So what we use is that we know 1 mole of H2O on the periodic table is 18 grams. So I'm going to go ahead and throw that in there. The next thing we do is we double check that we set it up correctly, and so we're going to go ahead and cancel our units. The reason why our units cancel out, as you can see that I extended the line here, is because when you multiply by that fraction, you're really putting everything on top of the fraction. And so that means whatever is on top is canceled by whatever is on bottom. So our moles of H2O have now canceled. We're doing this correctly. And then we just multiply across, and then if there was anything on bottom, we would divide by the bottom, but there isn't in this case. So 2 times 18 is going to give us 36 grams. So in other words, 2 moles of water contains 36 grams of water, essentially. Okay, so what if we want to go the other way? So now we have how many moles are there in 9 grams of water? So again, the first thing we do, we take our given, write that down. Our given is 9 grams of water. We're going to multiply that by a fraction, right, by a conversion factor. So I'm going to go ahead and put my fraction line in. Now, what units should we be putting on bottom is the question. So what kind of units should we have there? Well, we know we want grams gone, right? We know we want grams of water gone. So I'm going to go ahead and put that on bottom. And I know that there's actually 18 grams of water that are going to be in the 1 mole that I'm using. Because remember, we always put 1 mole in our conversion factor as well. So the first thing I would actually do is to just take grams of H2O, put it on bottom, and then I would say I need 1 mole somewhere in here. So then, since I already put grams on bottom, the 1 mole must go on top. Then I would think to myself, well, 1 mole of water is 18 grams of water. We know that from the periodic table, which was explained in another video if you want to go and review how to do that. So now we double check that we set it up correctly, so we make sure our units cancel. We have grams on top of the fraction and on bottom of the fraction, so we know we set this up correctly because we're only left with the unit that we want, which is moles. So we're doing pretty well so far. Then we multiply across the top, multiply across the bottom, so 9 times 1 is 9. There's nothing to multiply across the bottom, so then we just take the top and divide by the bottom, so 9 divided by 18 is going to get you 0.5 moles. So in other words, 9 grams of water is 0.5 moles, or half a mole, essentially, of water, is what we just figured out. Now, the last two, again, you could have solved them in your head if you really wanted to, because 9 is half of 18, right? But here's an example why we have to do this process, because they're not always going to work out so easy. So how many grams of sugar are in 4.87 moles of sugar? Suddenly we have a decimal that it's like, ooh, I don't know. So just like before, we start with our given, 4.87 moles of sugar. Now here's the formula for sugar. You'd always be given the formula for these kind of things. You wouldn't have to just know the formula. So here's the formula for that. Next thing I know, I'm going to multiply by my fraction. So I do my fraction bar. And the next thing I have to do basically is I need to ask myself what units am I putting on bottom to make the units cancel? Well, I know that I'm putting moles of sugar on bottom, right? Because I need that to go away. And my conversion factor always has how many moles? Well, it always has 1, right? So I put that there, 1 mole of sugar with that formula, 1 mole of sucrose. And then at this point, I need to know, well, how many grams are in 1 mole of sucrose, because whatever's on bottom has to equal the top for our conversion factor. So we go to look, and if we add it all up on the periodic table, which I've already done, we would find that it's this. So the molar mass of sugar is 34.3 grams. I mean 342.3 grams of sugar, basically. Then, just like before, we make sure our units cancel on top and bottom, and they do, so we did set it up correctly. It's very important that people do that, because what often happens is people accidentally put 1 mole on top and grams on bottom, and then the answer is completely wrong. So then we just multiply across the top, and then we find that it turns out there are actually about 1,667 grams of sugar in that many moles of sugar. And so we solved that one. Next question, how many moles of sugar are in 855.75 grams of sugar? So now we're going from grams to moles. So we start with our given, just like always. And then we set up our fraction, just like before. And on the bottom, we know what units need to be there. Well, we have to have grams, right? And we know we have to use the molar mass of the sugar, which is 342.3 grams. And so that means on top must go our 1 mole that's always in there somewhere. Check that our units cancel. Bottom, top, they canceled. We did set it up correctly. And then we'd have to just divide the top by the bottom, and then we would get about 2.5 moles of sugar. So that's how you solve those. So that's it for converting from mass to moles and moles to mass. Thanks for watching. Remember, chemistry is everywhere.